Upper and lower bounds, or limits of accuracy, is a funny little topic, but I shouldn't say it's funny because it's actually quite a realistic reflection of the way the world is. It basically starts out from the point of view that everything you're given is rounded. So if I tell you that I measured the distance from here to Henley and I got 12 kilometres, you don't really know whether I got 12 kilometres because I might have got 11.7 and rounded up. You just don't know. And so this topic assumes that everything is rounded, and it asks you to lay down some possibilities for what it could have been. So here are some possibilities. It could have been 11.6, as I said. Could have been 12.1, as I said. This is all assuming that I rounded it to the nearest whole. It could have been 12.49. It could have been 12.499. All these things could have been what I actually got before I did the rounding and presented you as my final result of 12 kilometres. It could have been 11.51. It could have even been 11.5 because we know from primary school that we round up whenever you're on the dividing line between two numbers. What about 20? Well, here you really have to know whether it was to the nearest whole or the nearest 10 or whatever. Let's assume it was to the nearest 10. Well, it could have been 15, could have been 16, could have been 15.1, could have been 24, could have been 24.99, etc. Now, to make a GCSE question out of this concept, you can't just write these forever. What they ask you to do is instead say what the boundaries are that separate what's possible from what's not possible. So these are all possible. These are all things that could have led to that. These are all possible. They're all things that could have led to that. These are not possible. 14.9 would not have led to that. If I was rounding that to the nearest 10, I would not have said 20, I would have said 10. 25 is not possible. If the measurement was 25, I would not have reported it as 20, I would have reported it as 30. So that's not possible. Equally, 12.5 is not possible. 9.1 is clearly ridiculous. That would have led to 9. The GCSE question is to say, what's the boundary between the possible and the not possible? It seems to me that the upper boundary between the possible and the not possible is 12.5, and the lower boundary between the possible and the not possible is 11.5. In this case, the upper boundary between the possible and the not possible is 25, and the lower boundary is 15. Now, when I say that this is the boundary, I'm not saying it's one of the possibilities, I'm just saying the boundary. It's like how in tennis, if the ball lands on the boundary, it's counted as in, whereas in some parts of cricket, if something lands on the boundary, it's counted as out. It's just the way it is. This boundary is ticked, whereas that boundary is not. But it doesn't change the fact that it's the boundary, because anything above this would definitely get across. Anything above this would not get rounded to 20, it would get rounded to 30 or something else. And anything lower than it would count as in. So 24.99 was one of the things that I ticked. The lower boundary is 15. That does count, and anything lower than it does not count, because anything lower than it would have been rounded to 10, not 20. So think of these as the upper boundary and the lower boundary and all the things that get ticked and all the things that get crossed. The funny thing though is we never talk about them as the upper and lower bounds. We always say upper and lower bounds, but it's easy to remember because the word bound is just a shortening of boundary. Now, these questions are pretty straightforward because the type of rounding that I was talking about was pretty familiar to you. But what if I say, I don't know, 25 to two significant figures? Okay. Well, what you do is this. You imagine that this is the figure in the actual world. Somebody's reported to you that they got 25 meters or whatever. What you do is you imagine the alternative world where you're a little bit taller, or you're a little bit gutsier, or you're a little bit better at cricket, or just anything, or an alternative world where the world wasn't warming up, just anything else. And any like that. And what you do is you write around the real figure what the figure would have been in the alternative world that still has that many number of significant figures. So in the world where I'm a little bit gutsier, it's 26. In the world where everything's a bit more sunny in Britain, it's 27. In the world where my sister has 3 children instead of 2, it's 24. And in the world where well, something else, it's 23. And then what you do is you take any neighbouring items in this list and you subtract them. You should always get the same answer. You then take that thing and you divide it by 2, and then you add that on to the 25, or the central real world figure, and you take it off, and when you added it on, that's your upper bound, and when you took it off, that's your lower bound. Now this little procedure where you write a list of the alternative universes, that is just a little trick to get around the fact that sometimes it's not easy to think about significant figures, whereas if you're good with counting significant figures, even if you're not fully come to grips with what they mean, then it's quite straightforward just to write down some figures that have the same number of significant figures as these, but which are quite near to it. When you've got them, subtract any 2 of them, as I've done here. 27 take away 26 is 1. Divide that by 2, and then when you've got that, add it on to the central real figure, take it off from the central real figure, and they're your upper bounds and your lower bounds. Basically what this procedure does is it just helps you think about what the unit of measurement must be. Up here it was probably pretty clear that the unit of measurement was 10 kilometres. Up here the unit of measurement was kilometres. This thing here just substitutes for that.